Hi everyone, this is my ham Shiny app. It's a demo app, so it's only going to work with the data that's available with the ham package, which is hosprog hosp1 and CAS and that stands for Cronbach alpha scale. So I just wanted to quickly show you if you wanted to test it out. This is through RStudio's Shiny repository. It's a free version, so I only have a certain number of hours. So if it freezes or stops working on you, it might be that the time allowed per month has been used up. I can't remember what the allotment is. I want to say it's 30 hours, but that's a really broad guess. I'm not sure, but please feel free to go ahead and test it out. Again, this is only going to work for the 3 data sets in the Shiny app. You can go to my GitHub page to look at some examples that are in there and test them out here. The only difference between that code and the code that you need here is that when working in Shiny apps, you sometimes have to put the open and close parentheses at the end of different objects, like the one that represents the data and the one that represents the model fit. So let me just go ahead and get started. I have some example code below. So we're going to do this first example. We're going to look at it. We're going to do a differences in difference model. For this heading, it reads as below are some examples. Box number 1 is the default hosprog data. Box number 2, enter the model. So we're going to go up to box number 2. I'm going to paste that in. And then to run the model, I'm going to click yes on number 3. Before I do that, I want to show you what I meant about the object names that we need to use in the Shiny app. You'll see that mydata, open and close parentheses, that is actually the hosprog data name that's entered in box number 1. So when I put that in there, it calls that data. I turn that into an object in my code, and when I specify the model, I use that mydata. I think I can use just hosprog, but if you just want to cut and paste, a quick way that doesn't require you to type in a new data frame name is just to use that mydata. So what I pasted it is in box number 2 now. I'm going to go over to box number 3. I'm going to switch that to yes. The model has been run. And then I can put in output that represents that model I just run. I could just type in fit1, which means the first model fit, and they're all going to have that same name. Whatever model I come up with later will always be referred to as fit1. And then I can just click yes, and it'll give me all the different elements of that list that gets returned when I run a model. It's a lot to look at, so we probably just want to stick to something that's of key interest. So let's go down to the example I have at the bottom. We've clicked yes at box number 3. Box number 4, enter the results or graph. Enter the results of the graph you'd like to see. So I can print these 2 options. The first one is a summary of the model fit, of our regression model fit for the differences in differences model. I'm going to go back up to box number 4. I'm going to enter that. I'm going to click yes. And here's the standard regression results that we're used to seeing in the base version R. or the statistics package, I'm sorry. So let's go ahead and interpret the results. So we're going down to that bit of code. I'm going to go back up. I'm going to paste it in here. It's not a lot of data, so I'm just going to paste, and those results pop up automatically. Just to point out another part of the code, fit1, I mentioned it already, but fit1 is represents the model results. We have the open and close parentheses because we have a reactive function that goes behind this code, and that's how I call it. So I have my interpretations for my DID object, the intercept, the first coefficient, or the next coefficient, intervention variables are next coefficient, and we have the DID, the differences in differences result, and that's here. Negative 3.57 is our coefficient, and we get an interpretation for that. We can also do graphing here. So let me go down to the box because I do have a section for some for graphing options. So if I want to do a prediction plot, I'm just going to copy this code over, scroll up to number 4, paste, but you'll notice nothing happened, and the reason is that on box number 5 I still have it set to results. So I just pasted in code for a graph or a plot. So I'm going to select graph in box number 5. Okay, so here's our classic differences in differences graph. You can see we have in the legend on the top left, we have a solid blue line that represents the intervention, a solid red line that represents our control group, a dashed blue line that represents the counterfactual, the what could have been part of the graph, and then it's a little light, but you can see a dashed gray line at the bottom that represents when the treatment was, when the intervention group was treated. So we see that's right at 0.5. For this analysis, we just have a pre and a post. We just have 2 time points. So we're just going to put in that dashed vertical line right in between the two. And so we get that graph. So let's go back down. We have another graph that we can plot. And that's for my variable importance. You'll notice that in these lines I have 2 for parameters. And that's just to help give us a nice display. In the R package, it just has the standard default settings, and you can modify those to give you a better display if you'd like. And so you can do that in this Shiny app as well. We're just going to add in the parameter settings, one for the margins and one for the OMA. And you'll notice that we have a semicolon at the end of each of these rows, the first 2 rows. And so that's, and the reason why is we're going to enter all 3, we're going to copy and paste all 3 lines back into box number 4. So let's clear that, enter our parameters in our plot code for our variable importance plot. And here we go. We have our results. The DID estimate has the most variable importance, and you can easily see that with that red dot to the far right on this graph in the bottom row. Variables with the most importance end up at the bottom and have the coefficients at the bottom also have those dots furthest over to the right. So that's what we're looking at. Okay, so we've done a differences model. We can do linear or logistic regression, and we can do an interrupted time series as well. And I don't have the code here, but I'm going to paste it into the description. We can do Cronbach's alpha scale. So let me just grab that code I have set aside here. So I'm going to do this alpha, and this is in the GitHub README page. So I'm going to clear that box number 2, paste in that alpha code. It's already run the model. I don't have any graphing options, so I'm going to clear box number 4. And then we're going to look at the model fit. So I'm going to paste that into box number 4. I'm looking at text output, so I'm going to click on results. So results have been selected in box number 5. Oh, I made a mistake. I didn't put in the correct data frame name. It's CAS. Okay. So these results make sense now. You can see we have scale statistics such as the overall alpha, the overall mean, the overall variance, overall standard deviation, the number of items. At the very top, then we have item statistics. We have 5 items, I1 through I5. We have the means, variances, and standard deviation, and these are kind of standard results for Cronbach's alpha. And another thing that's a common type of output would be the scale statistics if an item is deleted. So we can answer that question. Well, I know what the overall alpha is for all my 5 items, but could I trim that further? In healthcare surveys, we often want to have have a parsimonious model where we have the fewest items. It's a very taxing experience to go into a hospital, get treated, and get discharged home. So during that stay or at the end of the stay, we just want to make sure we can get patients back home and comfortable again. And so we don't want to overburden them with too many survey questions. It would be great if those 5 items do have the highest alpha available, but we see that for that item 1, if we remove that item, for the remaining 4 items, it would have an alpha of 0.93. And we see that at the very top for those 5 items, the alpha is about 0.92. And that gives anything above a 0.9 is usually considered an excellent level of alpha, especially for 5 items. One easy way to increase your alpha is to add in more and more items. So if you have just a 5-item scale that has the potential to get a higher alpha by going down to 4 items, that's something worth considering, especially if you're trying to limit the amount of survey questions you give your patients. So when we look at item 2 through 5, we see that alpha doesn't really improve at all, or doesn't have a higher alpha by removing one of those items. The remaining 4 are never as high as 0.919, except for that first item, item 1. If we remove that, we should get a higher alpha. So let's go ahead and do that. We're going to go up to box number 2. We're going to delete that first item, I1, in the argument for items. Okay, so we scroll down, we see that yes, that new Cronbach's alpha is 0.93. That's higher than the alpha for 5 items. So we get that output in our object, calling our model fit object. So let's interpret the results. We can interpret results for the scale alpha. So let's go down to box number 4. We're going to clear that, paste in the command or the function to get interpretations, and we now have interpretations. Your 4-item scale has a Cronbach alpha of 0.93. This is generally considered as being in the excellent range. The scale mean is 3.84 and has a standard deviation of 0.73. Removing one of these items, and it's a blank spot, so that means there are no items, can improve Cronbach's alpha in a new scale to a higher level than the current alpha based on all of our items. So right now there's no item that we can remove at this point to improve alpha. This is the best and most parsimonious scale that we have. That last row tells us about our sample, 0 rows of data excluded from the analysis because of missing data. In other words, there was no missing data, so no rows had to be excluded from the data set. Alpha does use list-wise deletion, so if we have one of those items with missing data, that whole row gets removed. Okay, so that's it. That's how we can use this Shiny demo app to just give it just to test it out, try it, and just go ahead and see if it's useful for you. I hope it is, and I hope this can benefit some of the work you're doing. Thank you.